So today we are doing the AP Calc AB free response questions from last year. Because pretty much everybody by now has finished all of the curriculum, right? Or at least you're really close and you're into review mode. So we're going to get into review mode. So we're going to do these questions. I haven't seen these questions, so I might have to muddle through some of them. But we're going to do them. And here's the thing about doing free response questions. If you're going to do free response questions, you have to check your answers. So those are our questions, and we got the scoring guidelines right here. So we also have to go through and we have to make sure not only that we got the answer correct, but that we got all the points and included all the work that we needed to show. So that's what we're going to do. And then also the first two questions are calculator, and I'm going to be trying to use numworks. If numworks doesn't cut it, I'm going to switch to Desmos. Because Desmos, like if you have like an Inspire or if you have an 84, it can do anything that Desmos can do. I'm pretty sure. Numworks is a little stunted because it doesn't have CAS. But we're going to try to use it because it's pretty good. It'll do most everything for us. All right, so let's go. Number 1, from 5 a.m. to 10 a.m., the rate at which vehicles arrived at a certain toll plaza. Oh, I've done this question. I think I've seen it before in College Board. Whatever you call it, the College Board online stuff. Anyway, write but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m. to 10 a.m. And they even tell you that's t equals 1 and t equals 5. That was nice of them. So, well, this is the rate, right? So the whole idea about this is that if you integrate a rate, you get a total number. So if we want the total number from 1 to 5, I was going to come down here and have our answers down here. So 1a, it's really just a one-line. There's really not any work to show. I don't think. You just have to do the integral from 1 to 5. We could even say of a of t, right? You don't even have to write all that out. A of t dt. If they need to, I would go ahead and copy it out. So it's the integral from 1 to 5 of 450. I don't know why they don't want you to evaluate it. You could just put this in the calculator. This is the calculator question of sine of 0.62t. But you probably could have just left the first part. Okay. So then let's do B. Find the average value. So the average value from 1 to 5, and they actually want us to find it. Okay. Well, to do that, you just have to take the total number, which we just did up here, so this integral, and then we have to divide it by the total number of hours. So the answer is just going to be this divided by 4. And then I guess they do want us to actually calculate this out. So we're going to remember to do the squiggly equal sign, because it's probably going to be rounding, and to do units. Remind me to do units at the end. Okay. So we have to, I'm not even sure that we can do this from here. Calculus. Beautiful, beautiful, beautiful. Okay. We even can write it pretty. So integral from 1 to 5. Is it can do definite integrals because it can just do that by brute force. It can't do indefinite integrals. This is the problem. So we'll just use x because it's already doing dx. And we'll just hit enter. So that would be the answer to the first question, and then we'll divide by 4. So it's about 79.4 people. How do they want us to round? And is it people? On the average rate of value in vehicles, okay, so vehicles per hour at which vehicles arrive at the toll plaza. Right, and it's per hour because we divided by 4, which was 4 hours. So this was getting the total number of people. This was hours. So now we're in people per hour. Does it tell us how they want us to round? I'm usually happy with 1 decimal place. I'll leave it with 1. Okay. C is the rate at which vehicles arrive at the toll plaza at 6 a.m. increasing or decreasing? So is the rate increasing or decreasing? Okay. So we want. So you think if you want to know if a value is increasing or decreasing, you got to take the derivative, right? So this is the same thing. If we want to know what the rate is increasing or decreasing, we're going to take the derivative of the rate and see if it's positive or negative at t equals 1. So let's come down here. We're going to find, basically we're just going to find a prime of 1. So to show work, that should be fine. And then we're going to try to do that in numworks. How are we going to do that in numworks? Let's go back to calc. Is this the derivative at a certain spot? I think it is. So we'll say, what's the derivative of that function we just had? 450 times the square root of sine of 0.62x. Make sure the parentheses are right. Yes. And we want that at x equals 1. Okay. So it's approximately 23.4. And then I would say something like, because a prime of 1 is greater than 0, the rate is increasing. Okay. I like that. I think that's good. Let me check. Just because I'm not sure I've ever used that function in numworks before. So let's type that into Desmos to make sure it's right. So Desmos, how I would do this is I would say, so we know that f of x is, what's the function? 450 times the square root of sine of 0.62x. Whoa. Oh, okay. And we're only looking from 1 to 5, I guess, is the deal. And then what do we want? We wanted to find f prime of 1. They said that was 100? Hang on. What? Did I type something in wrong? No. Why is that not calculating that same thing? Oh, is it radians and degrees? They're probably both in radians. And they are both positive. Oh, it is in degrees. Desmos is definitely in radians. Numworks defaults to radians. I didn't realize I had changed it at some point. Okay, so let's redo this. Nice. Okay. That was it. So either way, radians or degrees, it would have been positive either way, so it wouldn't have mattered. But I was confused by getting the same number. I wonder what the answers say about that. I'll leave a little note for myself using degrees. If using radians, it would still be positive. I mean, we probably should be using radians here, right? We always use radians. It doesn't say, though. Since we're talking about the rate, that's all that really matters. Okay. A line forms whenever A of t is greater than 400. Whenever the rate of people coming in is greater than 400. Well, then it will matter if we use radians or degrees. I mean, it's just always radians, right? So maybe let's relook at our work here. Well, we already have, if it's radians, it would be 148.9. So let's do everything in radians now, because it is always supposed to be in radians. Okay. A line forms whenever a of t is greater than 400. The number of vehicles at time t for a is less than t is less than 4, so between a and 4, is given by n of t, the integral from a to t. So that's just basically an equation where a of t, where a is the time when a line begins to form. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza in the time from A to 4. Well, we could find when A is, right? Because that's when the line begins to form. The line begins to form whenever A of t is greater than 400. So what would we want to do to that? We already saw the graph on Desmos. This is the graph of something else. So maybe we type in the equation here so we can try to see it. This is kind of hard though. I'm not entirely sure exactly what's going to happen here. So 450 times the square root of sine of 0.62x. So here's our graph. Boom. And so they're talking about when is it 400? Can I do that? Find x given y. Yeah, that's actually exactly what I want. I want when y equals 400. Will it show me all of them? Yes. Wow, look at that. Then I can just go left and right and see all of them. So I know that the time that the line starts forming is 1.47. Okay. So 1.47 is when the line starts forming. So that's when A is. A is 1.47. But what do they really want to know? The maximum number of vehicles in line. So that's n of t. Oh, so we want the greatest number of vehicles. We want to maximize the number of vehicles in line. And this equation gives us the number of vehicles in line. So what we want to do is find the maximum of that equation. So you have to think, how do you find the maximum of an equation? You take the derivative of it, right? So let's bring this down. So we want to take the derivative of that. We want to find when does n prime of t equal 0? Or undefined. Probably not undefined, though. Okay, so we want to take the derivative of that. So how are we going to take the derivative? So this is like the fundamental theorem idea, right? If you're taking the derivative of an integral, they're canceling out. So all we end up having to do is plugging this in to here. So does n prime of t equal a of t minus 400? Because the a just doesn't matter. Because the idea is if we took the integral, I mean, we could even just do that by hand. If you took the integral, it would be like the integral of a of t minus... Well, wait. Put the x here. Minus 400x from t to a. So it'd be the integral of a of t minus 400t, and then minus the integral of a minus 400a. The whole idea is now we're going to take the derivative. That's just a constant, so that's just going to go away. So what we're left with is just the derivative of the integral, so that's just straight a of t, and then the derivative of 400t minus 400. Yeah. So that's n prime. So what we want to do is we want to say, when is that equal to 0? So that's equal to 0 whenever a of t equals 400. That doesn't totally make sense, does it? Or is that a minimum? I mean, that is kind of a minimum. So is the idea you have to find the critical values and then the endpoints. So we also have to check at those. But A was when it was 400. Well, there was 2 points that it was 400 in between there, right? 3.59. So we have, so A was 1.47. When is the 0? So that gets us at T is 3.6. And then we also have the boundary to check. So we have 3 different values now we have to check. Because that's the whole idea. You plug in, you set it equal to 0 to get your critical values. So now this is a critical value, this is a critical value from that. We also have the endpoints, which is the 4 and then already the 1.47. So now, oh gosh, well I was going to say we have to find n of all those, but that's a pretty complicated equation. I suppose you could just plug it in though. So let's go back to the calculation page. And so we're going to type in the integral from 1.47. Well, at 1.47 it's just going to be 0. So we don't even need to check 1.47. That's just going to be 0. That's just not going to be a maximum. I imagine it's going to be to 3.6. So let's go to 3.6. And it's going to be of this kind of wild function here. So A, oh gosh, what is the function? A is 450 root sine of 0.62x, close. Already had a close. So that's the A function right there. But then we have to subtract 400. So that's n with 3.6 instead of t. Go. 71 people in line. So here there would be 0 people in line because that's when it just started. Here there's 71.25 people in line. And then at t equals 4, probably not. Surely it's gone back down at t equals 4. At t equals 4, it's down to 62. So the maximum number of people in line, should I go back and try to get a more specific answer? What was it? 3.597? I mean, that's pretty close to 3.6. So 71. 71 cars, vehicles. Ooh, I need to change the unit because I did people still. That's vehicles. 71 vehicles. This was vehicles per hour. All right, I'm pretty confident with that. Did I show all of my work here though? Not really. Let's look at the scoring guidelines though. I think I did pretty good. So, A. Oh yeah, they just straight up wrote the integral from 1 to 5 of a of t. Yeah, they wrote the first thing I did. Wow, so they thought about it's okay to put the absolute value as well. Wow, you earn the point if you forget the dx or the dt. If you copied it down wrong, you had to write 1 to 5 first. Okay, so we should have just stuck with this. Good to know. We should have just stuck with that. All right, B. So, I mean, we did it correct, right? What was the answer? Oh, whoa. 375? What? I got 79? What? Yeah, then I divided by 4 because that's multiplied by the 1/4. How did they get 375? That doesn't make any sense. Yo, what's up, Jury Goose? We are having problems with this question. How did I type in the integral from 1 to 5 of 450? Are they in degrees? But it was higher when I was in radians, right? Or did I not switch back and calculate this in radians? Oh, that's what happened, right? I didn't switch back and calculate this in radians. Does it say anything about that? Yes, degree mode. A response that presents answers obtained by using a calculator in degree mode does not earn the first point it would have earned otherwise. The response is generally eligible for all subsequent points unless no answer is possible in degree mode or the question is made simpler by using degree mode. In degree mode, you get what I said. So you do really have to be in radians mode here. That's annoying. So what does it say? Does not earn the first point it would have otherwise earned. So I used the proper formula. I got 1 point for the proper formula, but I did not get the point for the answer because I did it in degrees. That's too bad. Especially when I realized it later. I realized it for the next question, for part C. So we got A prime considers A prime of 1. Answer with reason, because A prime of 1 is positive. Degree mode, you get all the points because of what I said. In radians or degrees, it would still be positive, and that's all that matters. Got it. A line forms, yada yada. So what was my answer? Did I get the answer right? 71. Oh, I said 70. No, I did say 71. Nice. So I got the answer right. So considers n prime of t equals 0. I said that right here. T equals A and T equals B. A and B. They didn't even talk about a B. That's just their other critical value. So I did that. Answer and justification. Did I justify? So I considered it. I considered that. T equals A and T equals B. I mean, I did that when I said all the things. And I checked the endpoint just like they did. So I got everything, right? I think I got everything here. I think I got everything here. Okay. Let's go to the next question. Well, except for that one part, just because I was in the wrong calculator mode. But I think I got all the points. All right, next. Let f of g be those functions. You see them there. So this is f because that's the log. This is g because it's the polynomial. The graphs f and g shown in the figure intersect at -2 and b. Okay. Find the area of the region enclosed by the graphs of f and g. All right, got it. So numworks is actually prime for this. So what you can do here is you go to home, you go to grapher, you go back to the expressions, you type in the one equation. So the one equation is the ln of x plus 3. And then the other equation is... Do I have to type y equals? Probably not. Let's try it without. Is x to the 4th plus 2x cubed. Boom. Yep, put the y equals for us. Go to the graph, and there's our graph. Gorgeous. So now what we're looking for is find the area enclosed by the graphs. So on numworks, we can go here, toolbox, find area between curves. Select lower bound, where they intersect, -2. Select upper bound. Is it going to pop it for us? Where they intersect? Yes, it is. Look at that. It is. We probably have to say where they intersect, though. So let's come back up. Oh, wow. No, we used the whole page here. So we're again going to try to do our answers well. So I'm going to say at 1a, we need to find when f of x equals g of x equals 0.78. 198. I'll go ahead and write it down all. So then, I mean, we're just typing into the calculator, right? I mean, what it is it's the integral from -2 to 0.78198 of f of x minus g of x dx. And numworks just tells us that is 3.6035. I don't know, they were freaking me out with the decimals in the last one. Yeah. Numworks is great. It just does that for us. Okay? B. So we already said what B is. Oh, well, since they did label it, let's go B, B, B. So we clearly state what B is right at the beginning. So then from -2 to B, let h of x be the vertical distance between f and g. So since we're only going from -2 to b, that means f of x is always on top. So the vertical distance is always f of x minus g of x. Okay, so we'll write that. B h of x is f of x minus g of x, because that's the vertical distance. And we want to find, is h of x increasing or decreasing at x is -0.5. So, just like on the last one, actually, we want to say, is h prime of 0.5 greater than or less than 0? So what is h prime? H prime is just f prime minus g prime. So, I mean, we'll just type that in. That's easy enough to do by hand, so I'm not worried about that. So let's type in the derivative of f prime is 1 over x plus 3, but we're plugging in 0.5 for x. So 0.5 plus 3. So 3.5. And then minus the derivative of g. So simple power rule, 4 times 0.5 to the third. And we're still subtracting this, so I'll go ahead and distribute the minus. Minus 6 times 0.5 squared. That should be right. minus, so before I even look at the answer, make sure I typed it in right. 4 times 0.5 cubed, because it's 4x cubed. And then it's 6x squared. So minus 6.5 squared. And it's minus because we're subtracting the whole g of x. And what do we get? Negative 1.71. So g of 0.5 is roughly negative 1.71. So that means, therefore, decreasing. Yeah. Right? Oh, dude, Samuel, I see you with the gifts. I appreciate that. Oh, that's a lot of diamonds. All right. So next, C. The region. Okay. Let's look and let's make sure that even makes sense. So at 0.5 is right here, and we just said the area between them is decreasing. Yeah, that definitely makes sense, because that's the vertical distance. And that it's hard to see, but that's definitely smaller, right? Can I use a different color to hopefully show it better? It's definitely getting smaller there. Yeah, slightly. Ever so slightly. Okay. C, the region enclosed by the graphs F and G is the base of a solid. Got it. Cross sections of the solid are taken perpendicular to the x-axis. Perpendicular to the x-axis. So that's this way. Are squares. So we want to find the volume. So you just have to try to picture that. You have to try to picture it's all of these different squares. And what's the area of that square? So the area of each of those squares is going to be the distance, because that's the base of the square, the distance between the graphs squared, right? Because it's a square, so the height is just as tall. So the area of one of the squares, well, we already defined h of x, so we'll just write is h of x squared. That's the area of the squares, of each square, h of x squared, because h of x was the distance between the graphs. So now to get all of it, we just have to do it from -2 to b. So we have to do the integral from -2 to b. And there's no pi's going on, because we're not doing any like rotation. There's no circular motion going on here. It's just we're making squares. So you find the length of the square, which is the distance between the two graphs, and then you square it, and that gets you the area of the square. And then you just zoop, do it across from -2 to b. So now we just got to type this in, which is going to just kind of be a little tedious. Desmos would be much easier to do this in. But we'll still grind here. So what was B? B was 0.78198. And then we're trying to do f of x minus g of x. So let's do a big open parenthesis, so we'll be able to square it. And then f of x, ln of x plus 3 minus g of x to the fourth, distribute the negative, minus 2x cubed. And we need to square that. So that's h of x in the middle, f of x minus g of x. And then we're going to square it, and we're going to do that from -2 to 0.78198. And that's really all the work you should even have to show for that. So that should be is approximately 5.34 units cubed. It's all just in units, so we don't really need to specify that probably. Oh, but now I feel like I want to write it. Units cubed. I should be right. D. This is a rotator, right? Oh, no, it's not even. A vertical line in the XY plane. Let's erase everything we got up here, so we're going to have to look at this graph. So we got the vertical line in the XY plane. Travels from left to right along the base of the solid described in part C. The vertical line is moving at a constant rate of 7 units per second. So I suppose in the positive direction, because it's traveling from left to right, so yes. Find the rate of the change of area of the cross section above the vertical line with respect to time when the vertical line is at position x equals negative 0.5. Whoa. What are they asking for? Vertical line is traveling from left to right along the base of the solid described in part C. The vertical line is moving. Find the rate of change of the area of the cross-section above the vertical line. The area of the cross-section above the vertical line. So that's just the area of the square. The area of the square at that specific x value that they're talking about. So they're talking about the area of the square, which we've already said is h of x. H of x is the side length of the square. So the area of the square is h of x squared. That's the area that we're talking about here. The area is h of x squared. So then what do they want to know? They want to find the rate of change of the area. So how do you find the rate of change? You find the derivative. What's the derivative of this? A prime is a little power rule, chain rule. 2 times h of x times h prime of x. Don't even really need those. And then they just want us to plug in 0.5. Let's bring this down here with the rest of our work. So this is D. We have that area, so the area is h of x squared, which means the rate of change of that area is 2 times h of x times h prime of x. And then now we just want to find a prime of negative 0.5. That's what we're caring about, right? At negative 0.5. All right. So I've just kind of got to tediously type that in, I suppose. Oh, gosh. I don't really know. Let me see this. So I have, what do I have over here? Oh. I don't know if I can use functions like I can in Desmos. So let's go to... Well, I can have it take the derivative itself, right? So let's actually just type in, oh, and then can I just pilfer it from right here? This is h of x squared right here. If I delete all of this stuff, so come up here, delete the integral. Yes, that's h of x squared. So then what do I want is I want the derivative of that. Why won't it write that in there? That's obnoxious. What? Are you kidding? Oh, wait. I can just do... Here. Enter. Do this. Boom. Do that. There you go. There you go. There you go. And we want that at negative 0.5. So you see how that was h of x squared that we had up there. So now we're taking the derivative of h of x squared at x equals negative 0.5. And it is negative 1.32. And so what were they asking for? Is it increasing or decreasing? Oh no, just find the rate of change. I never used the fact that the vertical line was moving, did I? Did that matter? How would I even incorporate that? Oh, I didn't change the stream category. Is it because all this is based on x as opposed to time? Hmm. Do I just need to multiply by 7? I'm actually not sure, honestly. I think I would just multiply by 7 now. But I'm not totally sure where I would even incorporate that. Let's see if that's the right answer, at least. Just because it's going like 7 times as fast? I'm not sure where you'd incorporate that. Okay. That's as good as we're going to get here. Let's look at the answers. So find the area. 3.6035. We got that. The integrand, the limits. They went a little more decimals than we did, but that's totally fine. Yes, we did that beautifully. Next, B. Decreasing. Yes, because h of... Oh, that was supposed to be at negative 0.5? What? Ugh. And I plugged in positive 0.5? But I still got the same answer, so I'd probably... I don't know. I didn't consider h prime of negative 0.5. That I did do f prime of x minus g prime of x. I just didn't do it at negative 0.5. Is there anything about if you typed in the wrong number? I don't know. I don't know what they'd say to that. I got the right answer. I just did it at the obviously wrong place. I'd probably just lose 1 point. It's unfortunate. I got the right answer. Volume 5. Yeah, I got the right answer here. So I guess you need to do 3 decimal places. Okay. You do just multiply by 7. Why do you just multiply by 7? So you're doing the derivative of a of t. That's like a weird chain rule thing. Oh wow, they really wanted you to do that too. Yeah, the cross section is a of x. I did that. Oh, but we're taking it with respect to t. At least I was right. I just threw on the random multiply by 7. Oh my god, if you didn't distribute the negative, there was like a global special case that they had to deal with. That's so annoying for them. Well, I did write 7 times a prime of negative 0.5 right there. Where k is a declared value of any other. I don't know. I got it right. But I'm not sure if I incorporated everything they wanted us to incorporate here. So the whole idea was that you do have this a of t that I set up. Or a of x that you have set up. Did I write a of t or a of x? I just wrote a. But I did it in terms of x. But then when we take the derivative, we're taking the derivative with respect to t. So then what's the idea? You're taking... Well, that means just ax is supposed to be like a constant. But they're taking the derivative. They're saying the derivative of a with respect to x. Okay, I guess that's what you do. That's like chain rule. So we're taking the derivative of that. So that means we have a prime of x times dt, or no, times dx dt, because when it's y you do times dy dx. So this is, we're taking the derivative of x with respect to t, so it's times dx dt. And then so right here, what is dx dt? That's how much is the x value changing per second. They told us that that was 7. So that's where the multiply by 7 is coming from. Ooh. Okay. I guess that makes sense. Should we do more? Those are the 2 calculator questions. That took us a very long time to do those 2 questions. But also because we were checking our answers. I think we're going to leave it there. That's already a long video. So we'll come back later with the non-calculator questions. And hopefully those go quicker, because we won't just be spending so much time typing stuff into the calculator.